Welcome, everyone. Thank you so much for joining us. We really appreciate you coming out on a Thursday and talking to us today. We're going to be presenting Python-powered serverless observability. So this will be a very fast talk. We've got a lot of content to get through. The good news is we've also provided a GitHub repo at the end of this that's going to give you a walkthrough of all of the code that you see. So please don't feel like you need to take pictures of slides or anything like that. We've got it all captured for you here. But Brian and I are here at PyCon 2024. Couldn't be happier to be here. This is our second PyCon speaking together. And we are from Capital One. So if you would like to get in touch with us, this slide you're welcome to take pictures of. My name is Dan Furman. I'm a distinguished engineer with Capital One. I work in our enterprise cloud foundational services space. And Brian?
My name is Brian McNamara. Like Dan, I'm a distinguished engineer, but I work in a different line of business. I focus exclusively on serverless technologies.
So whereas I'm a little bit more of a generalist, I have been a Pythonista for about 15 years now, so there's been quite a few of the ups and downs of Python that I've been through, and most of what I develop these days is in serverless, and most of what I help teams architect is in serverless. So as we've gone through and had a lot of our learnings from Capital One, one of the things that we've found is people worry about observability, and how do we actually go in and track the application. A lot of times we kind of inspect in quality in the Python world. You can SSH into the box, you can grep through logs, you can run top commands, you can get all of that kind of stuff. That's not really an option in serverless, and frankly, that's a good thing, which we'll get into a little bit more. So, again, going through this, we've gone through our introduction. We will do a super vast overview of what serverless compute is. We'll define what observability is and how we are doing an observability setup for you. We'll talk about those pillars specifically with a lens on AWS Lambda, because serverless application and API development is what we're going to focus on today. This works with any cloud provider. We're just using AWS as an example because it's nice, it's concrete, and it's what we happen to work with every day for the two of us. We'll go through a summary, a Q&A, and we will spend the bulk of this session in code. So why Python for serverless? Simple is better than complex. This sounds like a thing that you probably know. Import this, and you will see a lot of things that have synergies between Python and the serverless ecosystem. Python's REPL loop and the ability to quickly give feedback to developers is one of the main reasons to use the language in general. And one of the cool things about the serverless world is Python is ridiculously fast when it comes to serverless functionality. If you think about the way that serverless functions work and the way that serverless works in general, what you're waiting on is for the event to get passed into something. Welcome, come on in. You're waiting for the event to get passed into something, you're waiting for the language to start, and you're waiting for your program to then parse and deal with that event. Because Python starts instantly, because the interpreter's already there, everything's already set up, you're ready to go, your dependencies and your packages are already in place, you can process those events within milliseconds, which gives you a huge advantage in the serverless speed space. So anytime somebody says, but Python's slow when it comes to serverless functions, they're just wrong. Which means Python becomes one of our obvious choices here. Again, fast development cycles, fantastic scaling. We can scale out hundreds of thousands of functions if we need to in order to get this done. And because we're billed by the millisecond, at least in the case of AWS Lambda for this, it can also be a ridiculously cheap way to get things accomplished. I've seen Docker containers running on various technologies that are really good with concurrency that cost roughly 20 times what it costs to run that same function in Python-based Lambda functions. So not only is it fast and easy to write prototypes, those prototypes then scale instantaneously as you need them, which is a really nice thing to do. If you consider one other aspect of this, there's another aspect to the cost equation, and that's total cost of ownership. Your hours are probably the most expensive thing that you have available to you, and the more of your hours that you're spending maintaining all of these different code bases, restarting daemons, auto-scaling things, dealing with all of that, the less time that you're spending actually doing things that are meaningful for your customers. We want you to do the things that's meaningful for your customer. And hopefully that's part of why you're here at this talk today, is to see how do I get the observability part of that and get through that for the serverless. So what does serverless mean? I've said this term a bunch of times, but it's an operational model to reduce that toil. That idea that there is a given that when you run Python, you have to run Linux. When you run Linux, you have to run a kernel. When you run a kernel, you have to secure it and run it this way. None of those things are true in the serverless world. The cloud provider assumes more responsibility. They take care of the infrastructure, they take care of management, they take care of scaling, they look at all the resiliency options, and you just run your code. Your code moves up the stack, and it's only your code and your code's dependencies that you're actually writing or worrying about, which is a really nice way to do things. So since we're using AWS, I'm going to switch from saying functions to the word Lambda, but no, I mean them interchangeably for the rest of this discussion. And cloud providers, by taking care of these things, also take care of your security for you. So if you've ever had to patch a Python version that's come out because there's been a CVE in it, it's not common in our language, but it does happen. I would much rather let the cloud provider do that, and I would rather sleep. And this is one of the things that makes serverless so attractive to so many developers today. But let's talk about what it means to take on some of those operational responsibilities like observability. To answer that, let's start with what observability means. Understanding the system's internal state by analyzing the data that it generates. That's a really academic way to say this. Most commonly, these are signals. They come out as logs, they come out as metrics, they come out as traces. And it's important to note that observability is not the same thing as monitoring. Monitoring is a whole suite of things that you need to do. It brings in SRE functionalities. If you're in a large enough organization, it may just be you if you're in a smaller organization to come through. But monitoring and tracking what's going on is not the same thing as observing it. Observing what's going on is what happens inside of this sealed container that is going to securely run and run all of my code, and how do we make that work? Monitoring typically captures metrics like disk space utilization, processes bound to a certain port, whether or not that there is an event ready for something to be done. Observability is more holistic. What it's looking for is a signal that will tell you how is the system actually functioning today, and what is it going to do for facilitating your troubleshooting when you need it. The first signal we're going to talk about is logs. These are streams of order events, and they are facts. They're super useful when understanding why things are going well and why they aren't. They're great mechanisms to support exploratory troubleshooting, and this is the thing you're probably the most familiar with. Anyone who's heard of RFC 2119, the syslog standard, you probably have even heard of different log levels and log filters. These are the same thing in serverless applications, but you have to design them into the application itself. So what does logging look like inside of a Lambda function? Lambda has amazing integration with a service called AWS CloudWatch Logs. And that default output is meaningful even if we don't log any real information with it. We get our start line, we know what the request version is, we know what version of the function ran, we know that it was successful, and we added Brian here as a user. We got a 200 response code from that. We know that it ended. We know that the function gave us a summary report of what's there. It told us how long it ran, how long we're going to get billed for by the AWS provider, even what we configured the amount of memory that's approaching this function to do. As developers, to do this, all you do is send data to standard out. This is literally print 200. At that point, we get this information for free. So this is information that's already brought in there. But we can do much better for this. Structured logging is something that allows us to do that better way to do observability. Logs are meant for human consumption, and we need to search through them to see what we're going to get. In order to do log searches, we need to use native tooling like CloudWatch Logs Insights, or if you forward your logs, you may forward them to Splunk or Elastic or Elk, Datadog, whatever it happens to be. You can use aggregators to then search through what these lines mean. But if you used the JSON format for this, you have the ability to actually bring in structured logging messages. So we can see here, We've got message details about the submit user action being successful. Brian1 is the name of the user that came through. We even know it's an info level log, which is a really cool way to do this. Now, there is some more information in here. Again, all of this is available to you in our GitHub repo, so please don't try and take pictures of me scrolling on that because you're just going to hurt your eyes.
What's interesting is that the code scrolling isn't captured in the presenter view.
Ah, well then never mind. Sorry, the code scrolling is not coming through in the presenter view. I can make it happen over here. So, thank you. So let's look at what structured logging actually looks like. In order to get this data set up, we can write just basic Python code, and we can set up logger.info and send a dictionary to it. That dictionary gets auto-serialized as JSON, which is the easiest way to search any of this, and it will serialize out as Python native types. We can also log errors, and we can exit the function if something gets wrong. So we'll use this sample code to dig into a little bit more of the structured logging. This is what's actually produced by that structured logging without having to do a bunch of side scrolling on this. Notice all we did was we logged the message section. Everything else that came through as part of this came through as part of the standardized function library that we have imported here, and this is a best practice that comes through. It's all of the context related to the Lambda service itself, and this is done with one annotation in our code. As we look at what is available in structured logging, we can also search it specifically for specific fields. We can look for anything where the user ID is Brian1. We can sort these, and these are all just standard query kinds of actions that we're allowed to run within the system. So this is an example query that will go through, and that query will return the results that we need. Now, while it's certainly possible to use things like the Python logging module to emit what structured logs look like in the JSON format, it's possible to write and capture the Lambda context yourself and make all of this happen. These best practices have already been codified. So if you look at the open source library Power Tools for AWS Lambda for Python, it makes it much easier to write this because they've already done the formatting to all of these open source libraries. So the good thing here is there's no magic. At no point have you given over control of your code or given over control of your logging. And in fact, even if you're doing this outside of Lambda, these still give you the same structured formats for anything that would be a container or anything that would be just a bare metal VM. You can run this in your own data center. In fact, I run it on my home lab as equipment just because I'm used to seeing it as what's here. It's less opinionated, at least in our perspective, from the mechanism that you're going to use. But rather than grokking your logs, you want to make sure that you get the maximum amount of value from them. And this is a good way to get you started on that, even if you've never written a serverless function before. If this is the first one that you've ever encountered, strongly recommend start with the things that are already set up. I'm going to move a little bit faster now because while we're familiar with logs, we may be less familiar with the term of metrics. Metrics give us data measured over time. And the way that metrics are useful is in measuring the performance or whether or not certain events have occurred. So these are very business-specific values to your function. This could be successfully registering a credit card payment. This could be unsuccessfully registering a credit card payment. This could be a payment clearing or not clearing. These are the kinds of things that you're probably talking with your product people about anyway. Why not build them in from a design perspective? The more we work with our product people and we design observability into the application itself, the better quality observability we get. We're not always just trying to extract stuff from logs and hope for the best. Inside of Lambda, you get great integration with CloudWatch metrics, and you get some of these metrics directly out of the box. These things, invocation, performance, concurrency, asynchronicity, all of these give you statistics that allow you to see how is your overall application performing, and there are ways to aggregate them. I probably care about the total number of invocations, not the average number of invocations, for example. So we've given you some of the statistics here that you probably want to look at within the system.
Just to piggyback on that, if you're experienced with AWS CloudWatch metrics and you are looking at your Lambda metrics that are being emitted, make sure you're using the right statistic. Otherwise,
bad
I'll
things
say
can
things
happen.
won't make sense.
So a good example of that is customer experience. If your customer experience is being measured at the P99 level and you're just looking at the average of how long it took your functions to return, you are going to be very confused why your customers are upset, and your business partners are going to be very confused by the information in your dashboard. So make sure that you're looking at those metrics math things. It's a good analogy to say that metrics are kind of like peanut butter and chocolate. You get some really useful classes and metrics out of the box, and then you can add in your own things to make these more meaningful for your business applications. So, more metrics that we're not going to go through in detail, but probably ones that you're going to care about. Again, the more that you're concerned about each of these elements and the questions that you're trying to answer within, these are the things that are going to give you that. None of these are custom metrics at this point. All of this is stuff you get out of the box with serverless providers. And again, this is cloud agnostic. You will get this kind of information. It may be called something different, but you'll get this kind of information from everyone. So here's a sample set of what these metrics actually look like. They graph. Remember I said this is data over time. So this is something that you can actually show directly to a log provider or to a business partner and allow them to see how is your application performing and what's going on with it today. When these metrics are set up and you're looking at the indicator ages, you can see how fast you're being able to catch up with your queues, anything that's being throttled, anything that you need to worry about from an SRE standpoint, plus you can get to those business metrics that matter. So metrics are provided for operators and developers out of the box, but you want them to be relevant to business stakeholders. We can do this with a format called embedded metrics format that publishes custom metrics to the CloudWatch logs and then exports that directly. Here's what that looks like. Now, while it is a little bit of an eye chart to be able to look through what's going on, you can slice and dice these through different dimensions, and this is just part of what gets emitted into your logs without you really having to worry about anything here. So it's a nice way to make that work. Metrics have namespaces, definitions. The metric itself is, well, the metric. It's the thing that you're looking at. You've got the unit that it represents and the resolution. So you can get down to microseconds, milliseconds, seconds, minutes. All of these things can be aggregated into something that's meaningful because you're probably not measuring, microsecond to microsecond what's happening in your application. You're probably doing that on a minute-by-minute basis. So there's a few ways to get into that. This chart's a helpful one because it allows you to see some of the different dimensions that we're talking about. We've created a namespace here called e-commerce app. We have a shopping cart service, a product service, and a delivery service. And all of those things have custom metrics associated, whether the cart was updated, the product was added, the delivery was successful, how long it took to make that delivery to the client. All of these things give us the way to do that. And we've deep linked all of the documentation into AWS Lambda Power Tools so that you can see how to do that more in depth before we actually show you the code in just a couple minutes if I speed up enough. So let's dig into some of the sample code here. Like what's actually required to do this. That's a lot of data, it's a lot of power. But let's look here at just metrics.addMetric. Name is successful submission, unit is metric unit.count, and the value is 1. If we hit an exception, unsuccessful submission, metric.count, or metric unit.count, and value of 1. So that's all it takes to actually emit embedded metric format using the tools that we're talking about here. Those all integrate directly and produce all of the data that you're seeing. So none of this is something that is overly complicated or something that you need to go figure out because, well, simple is better than complex. So we're going to go ahead and map this to PyCon 2024 for instrumented user registration that you saw before, and we're going to go to standard resolution of our metrics. We could do high resolution, but why? And EMF allows us to publish custom metrics using these log events. The cool thing about doing this is it's completely asynchronous, which means your function doesn't slow down, which means your Lambda function can actually respond at API level speeds to be able to do this. Because it's non-blocking and you have the ability to go through, there are other mechanisms like AWS Embedded Metrics Python. Again, you'll find this for all different cloud providers. We're less opinionated about the mechanism you use, but we are going to say if you're using AWS, do not use the put Lambda or put metric data Bodo 3 call that happens That is a synchronous call, which means it's going to have to flush that queue every time that you do it. So that is a helpful tip for building your first metric-heavy application. The last signal we're going to look at is traces. Traces allow us to examine interactions outside of local boundaries and see what's going on inside of the black box here. Lambda has amazing integration with a tool called AWS X-Ray, and the default output is very meaningful. This is kind of like peanut butter and jelly rather than peanut butter and chocolate. You don't need to set a tracing daemon collector. Your aggregator works all in one. Your function has the ability to permit traces. All of this comes together very meaningfully. And that's all the code that's required to instrument it. You're literally talking about a couple lines of YAML here, and most of that is defining things like, hey, we're going to run this in Python 3.11 with a 5-second timeout, give it 256 megs of RAM, and all of that tracing goes when I say the word active, which is a really nice way to make that work. So here's what a function looks like. It immediately tells you that the function was called, the function in code internally was called, and we have the ability to look through what the base service map is. We can break it down further by looking at how much was invocation, how much was was initialization, how much of that was overhead, but we can get even deeper.
Actually, just real quick, Dan, if we can jump back to the previous slide for a sec.
Sure.
How many of you have heard of the term cold start within Lambda? Okay. So if
Who's
you're using...
scared by the term cold start in Lambda and hasn't done serverless because of it? All
cool.
right.
Awesome. The initialization line here represents your AWS Lambda cold start. So you always have a sense of what that looks like here.
So you can see exactly what's going on within that, and if you're lining a lot of that code into your cold start, you can figure out exactly how that's happening, and then you can use measures to counteract that. Talk to Brian and I afterwards in the hallway. We will tell you all of the ways to eliminate cold start, or at least take it down. Arguably, we can do better than that. That's all out-of-the-box functionality. You're here to learn something that's more useful than that. So that was without adding any instrumentation at all. Let's instrument our code. We can use wrappers from the X-Ray SDK to allow us deeper visibility in here, and that's going to allow us to say, hey, look, we made calls to us.pycon.org as part of this. So this is just the request module, and by instrumenting the request module out of the box with X-Ray, we can now see what the duration of the request was, and it gets automatically added to our service graph. The Python SDK supports quite a few modules here, including calls to other cloud functions. Again, we used requests here because we love requests. So now all of these tracing details come down here. You can see where's the function spending time. You can see how long it took to come back. You can even see the status code of what it took for us to call the PyCon website. We can annotate that even further, and we can look at the functions that are required around it. Maybe if we had to do some form of authentication, if we had to do mutual TLS headers or anything like that, we know that those are more CPU-intensive applications. If we want to prove that that's actually the cause of a performance degradation, we have the ability to do that just by wrapping this within some more tracing details here. So we can enrich and search on any of this data. The way we can do that is by making sure that we annotate what's going on into the data with more of the metadata code inside each trace, and you can see what the details look here on the screen. We can search as well, which is a really nice thing. I can look for any user ID called Brian1, and Brian1 will show me all of the traces that are related to it, which means if I have a highly distributed application across dozens of microservices, I can see the entire user journey from when Brian logged in to when Brian logged out, all distributed in one system, which is a really nice way to do that. Tracer, if this sounds complicated, if this capability sounds like something that would be very difficult to do, surprise, it's really not. We're just going to put some annotations for the user ID, the log, and the request ID in here. Those all get put into the tracer.put metadata function. This is the right way to do it. This is not something that's blocking. And you can see our function has grown by just 3 lines in order to make this work. So these are real-world examples, and this is not an oversimplification of what you would be doing in the first place. We also started with the line tracer capture method, and that's how we got the additional visibility of what is going on with this function itself within the Python application. If I could hit the right button. All right, Something to note, the fine print, traces are sampled. You can set the sampling rate anywhere from 0 to 100. Sampling is a good thing when it comes to tracing because tracing creates a lot of data, and I mean a lot of data. But being able to take random samples of that data, statistical laws tell us that this will give us a good insight into what's going on. You cannot change the sampling rate for your function within itself. It will be set for you, and it will be done at 1 request per second and 5% of additional requests. You cannot configure that within X-Ray for setting up. So I'm going to hand this over to Brian at this point. We talked about some cloud-specific providers with me. We went through logs, we went through traces, we went through metrics. Brian's going to talk about the thing that you've probably heard more often than not, and that is using signals through OTEL.
Thank you very much, Dan. So let's talk about OTEL. OTEL, or Open Telemetry, it's a framework used to create and manage telemetry data, like logs and metrics and traces. It's vendor and tool agnostic, so you will likely see a lot of SDKs available. Like, yes, there are SDKs, and yes, there are APIs for Python.
So many SDKs. Just look at PyPI; they're everywhere.
The main goal is to make it easy to instrument code. So if we consider the origin, so OTEL was really started as a merger of 2 different projects, Open Census and Open Tracing, back in 2019. Seems like a long time ago, but it's an ever-evolving space. So if you are, you're in this room, so I presume that you care about serverless observability. Stay tuned. Keep plugged in, just because things do change. So Dan already covered the general signals that we can receive from our underlying systems, like logs, metrics, and traces. Instrumentation is the ability or the process of emitting signals from each component. So we can get instrumentation through APIs or SDKs. There is actually a zero code option as well, and we're going to explore that a little bit further in our Lambda example. And the last term I'd like to cover is collector. So a collector is a way to, essentially, as you might imagine, collect all these different signals from your OTEL-enabled services, so that you can do some interesting things. Like, you can actually look at a collector as almost being like a mini data pipeline, where you can enrich information, coming from the signals. You can sample there. All sorts of interesting things can occur at the collector. And I mentioned one of the main benefits of OTEL is the ability to not be locked to a vendor. If you switch out, you can actually switch where your traces and logs and metrics are sent to just by updating a collector. You would not have to then update code. So a collector is essentially a way to collect all of the different signals and emit them to your OTEL backends. So one of the things that we didn't show yet was the code, but trust me, we will. So we have 3 different Lambda functions that we're working with. One is just a plain vanilla Lambda function, no instrumentation whatsoever. Dan showed what that looks like from a logging standpoint, metric standpoint, and tracing standpoint. Yes, there's value, but not a whole lot. There's another function that is instrumented a little bit more, but it's tied more specifically to AWS services. So we're using AWS Lambda Power Tools for Python to emit structured logging, collecting all of our Lambda context. We're emitting custom metrics. Within X-Ray, we're emitting traces with annotation so that we can search, arbitrary metadata as well. The code that I have for the OTEL function looks strikingly similar, but for a few things. One, it's missing the tracer component from Power Tools. And we're not adding any of the function decorators that we used in order to get the most meaning that we could out of our instrumented Lambda function. I chose to not use X-Ray. I mean, X-Ray is it's a valid destination for OTEL, but to show you that you really can send OTEL data elsewhere, we used Honeycomb. Honeycomb, how many, quick show of hands, how many people have heard of Honeycomb? Heard of Charity Majors? Okay, if you're in the observability space, I would encourage you to follow her writings, in particular, Liz Fong too. Super, super, super good people to follow in general. They started a company a few years ago. It's called Honeycomb. They have a pretty generous free tier, so that's why I went with them. But it's also a really amazing product. So.
By the way, there's nothing that stops you from doing X-Ray and Honeycomb or X-Ray and OTEL to be able to do this. Brian mentioned that OTEL is a valid export to X-Ray and to start with. We're doing this just to show you don't need any of this AWS specific stuff in order to do the OTEL piece.
Yeah. And if we can jump back just for a moment, the actual code that I have here, there's nothing in here that is Honeycomb specific. In fact, there's nothing really OTEL specific here. And this comes into play. I'll show you how we're accomplishing this in just a little bit. But we have the ability to emit our OTEL data. In this case, I'm only emitting trace data. We can emit trace data from our Lambda functions. In this case, we're using Honeycomb as our destination. Much like we saw with X-Ray, we have the ability to look at traces. And with each trace, we have the ability to look at spans. So for each component that shares a common trace ID root, we can see literally what's happening along the way. Honeycomb has this ability. We can get span details as well, so metadata or characteristics about the spans. Things like, in this case, the cloud provider, when the trace was traced, the region in which the trace was emitted from, all these different things. Honeycomb provides the ability to query, so we can actually use the metadata that's present in our traces in our queries. So in this case, it's a capability of Honeycomb. You'll likely see this in other trace providers as well. So this is a capability that's probably more generic.
And if you're thinking about other providers, New Relic, Zipkin on the open source side, Datadog is another SaaS provider. All of them offer similar capabilities to this. We just chose to show it in Honeycomb here.
Yep. So in this case here, we're querying based on the HTTP URL that's present in the metadata. So our Lambda function happens to reach out to the PyCon US website.
We're sorry if we DDoS'd you.
Thankfully, I don't think we're doing that much. So how do we do it? I made a point of bringing up earlier that we weren't specifically instrumenting our code. So in this case, we're using a zero code example of instrumentation. The good news is AWS provides a Lambda layer. Quick show of hands, how many people know what a Lambda layer is? Okay, if you don't, that's okay. Lambda essentially allows you to ship additional data that you might want to share among different Lambda functions. So you can share libraries or modules if you want. They also ship capabilities called extensions as well. So extensions allow you to plug into the Lambda execution environment. So they basically package all of this capability, the SDK, the collector, the APIs, all in a layer that you can take advantage of. So it's not code that you have to write or maintain, but you can certainly use. And we'll look at that code in just a moment. Long story short, we are basically using functionality that's already provided without needing to instrument the code ourselves. So 0 lines of code, to add additional value. We can specify our configuration values through the use of environment variables, as well as an OTEL specific config file. In the code example I have, again, it is admittedly 0 code, but we could enrich it. We could add the extra instrumentation if we wanted to add additional metadata to make those traces more meaningful. Metrics and traces are officially supported. As of today, the logging signal is not yet supported, but I know it is being used. So your mileage may vary. Things may evolve over time.
If you're interested in the observability space, you'll notice there's been a lot of changes in the last 2 years. Those changes will continue. Now that we have the standard locked down, all of the major providers have agreed on what it is, we're going to get more and more of the implementation of these things and more of what's happening in the open source community.
Here's where I'll take a brief break. I'm going to switch laptops. So
we're going to switch around just a little bit.
I'm not going to hum too much because that would be annoying. live demo.
That said, I'll go through just a brief summary here. To do good observability, it doesn't need to be tied to a cloud provider. You can tie it to anything that you want it to be tied to. You can use these packages regardless of what cloud provider you're looking at. If you design observability into your code as you design your code, the same way you would do test-driven development, you can do observability-driven development. And the more of this you do as yes and, not one or the other, the better instrumented, the better observable your code will be. And frankly, the more business questions you'll be able to answer without doing new deployments and then trying to reproduce conditions that have already happened. So it's a really exciting space to work in. And frankly, it's one of the things that gets us excited about why we do this.
So just to go under the covers a little bit more, I'm a big fan of a utility that AWS provides called AWS Serverless Application Model, or SAM. Quick show of hands, how many people have heard of SAM, use SAM, love SAM, hate SAM?
Name SAM.
So SAM is a template specification. If you're familiar with what AWS CloudFormation is, again, love it or hate it, SAM is essentially a DSL for CloudFormation, but it makes it really easy to deploy serverless specific things. Things like Lambda functions, Lambda layers, API gateway. So some of this is going to look strikingly like CloudFormation, where you have a declarative template, specifying what you want out of a logical unit, a CloudFormation stack. This SAM template was used to deploy the three Lambda functions that I mentioned earlier. So we have our vanilla function, literally stupid simple code, and we're basically taking an event. Dan mentioned Lambda is event-driven compute. We're essentially passing in an event and doing something with it. So we're able to use all the goodness Python offers, including Pydantic. So if we want to do input validations, we can do that. Here, I'm just really performing some really simple checks and calling a separate function that reaches out to the PyCon website. The signals that we saw emitted, the logs, there really wasn't too much exciting. It looked an awful lot like a standard Lambda log. The only thing that I'm emitting here is a print statement. Again, don't do this. You can do it, don't do it. Obviously it's very easy for us to read as humans, but if you have to search for events happening at scale, like if it's 2 in the morning and you need to really dive deep and fast, having to parse this information is really painful. The good news is, if you structure your logs accordingly, it becomes a lot easier. Dan mentioned there are external service providers to AWS, like Splunk or Datadog. If you run your own Elk stack, you can certainly take advantage of that. What you don't want to do is write a parser.
Friends don't let friends write parsers, just like friends don't let friends write WSGI.
If you haven't written I was going to say, if you haven't written a parser before, that's good, you're lucky. It's not a great experience. By structuring your logs, so I'm going to shift over and show you what that looks like in our instrumented function.
And to give you an idea of what's the scale difference here, you can scan 12 to 40 12 to 40 gigabytes of log data within under a second, versus trying to grok that stuff manually. You're going to spend almost a minute waiting for that same amount of data to search. So structured logging, very, very good thing.
Yeah.
This is true across all providers.
So the actual mechanism that we use to make this happen is we import a logger from AWS Lambda Power Tools. Again, there's nothing stopping you from using the standard library to do this. You certainly can. Power Tools just makes it a lot easier.
And Power Tools uses the standard library.
Yes,
it just
under
wraps
the
it for
covers.
you.
Yeah. And we can see too, there's an additional decorator that we use where we inject Lambda context. This is what enables us to get information like whether it's a Lambda cold start, what the function ARN is, all the additional information that might be relevant to that particular execution. It's all present without a whole lot of instrumentation code. Like, we're not adding a whole lot. Like you should be emitting logs anyway, but to get them in a structured format and to capture the additional context, there's very little instrumentation code that you have to add. When it comes to metrics, so I'm going to focus on the instrumented function here. As Dan showed earlier, it's really as easy as using the metrics capability, in this case provided by AWS Lambda Power Tools. Under the covers, it's using Amazon's embedded metrics format. And you may think it's a little odd to use logs for metrics. It is. But the good thing is it's a standard format that AWS can parse and then asynchronously create metrics on your behalf. So, the business level metrics that we were looking at, we had talked about very briefly, what it looks like in code. But let's take a quick peek at what it looks like within within AWS itself. So in this case here, we can see we do have our custom namespace PyCon. We can drill in deeper and say for the service we have instrumented user registration and OTEL user registration. In this case, we don't have any unsuccessful submissions, so yay, our application is doing what it ought to. But these are just metrics that we can add over time, and view what happens over time. What's cool about metrics versus logs? How many? Just quick show of hands. How many people alert? And I know this is observability and not monitoring. How many people raise alerts based on log events? Okay. I would say I'll challenge you on that. It's really, really common. I don't mean to say that you're doing anything wrong. But what I would say is consider whether those log events could be emitted as metrics. It becomes a lot easier. Like I think if you're running in AWS in particular, consider how you can use metrics in place of log alerts.
And think about what that does to your time to detect and your time to recover. If you're not waiting on some aggregator to pull your logs, figure out how many errors there are, and decide whether or not to alert you, you can cut up to 4 minutes out of your time to detect. Depending on what your sensitivity of your application is, 4 minutes can be the difference between a Sev 3 and a Sev 2 event.
And also can consider the opportunity to create visualizations. So if you're using a log tool like Splunk, it offers a really rich tool set where you can see visualizations of your log queries. Well, if you're using different systems to store your observability data, that means that you have to hop back and forth. My personal advice is to keep your observability data as close to the source as possible. So if you're using things like custom metrics, you have the ability to create dashboards and include that information. What's really cool too with metrics, you can take advantage of a capability called metrics math. Anybody know what metrics math is in AWS?
Anyone have a statistics background in the room?
I don't.
All of your statistics friends will love you for using metrics math.
So what's really cool about metrics math is that you can literally perform calculations based on your metrics and potentially raise alerts on the results. So is it always good to raise an alert when there's an error? Maybe, maybe not. It might depend on your application. Like, is 100 errors a lot? I don't know. What might you care about more is error rate. Errors as a portion of your overall requests at your application services. Well, there's no default metric for that. Like in Lambda, you see errors, you see requests. The good thing is you can actually combine those two and say error rate. So you can then raise alerts based off of error rate, not just a flat number like errors. You can do the same sorts of things with the custom metrics that you're creating as well, because they're just metrics. So if you see business level metrics, exceed a certain threshold or fall below a certain threshold, you actually have the ability to alarm based on that. And the instrumentation code that you need to do that, it's a line, 2. Like, it's really, really light relative to the benefit that it can offer. Let's take a peek at some of the tracing data, or some of the tracing code. So earlier Dan mentioned with X-ray, we have the ability to add, in fact, that's in the instrumented function itself. We have the ability to enrich our traces. So we're making use of the tracer package. We can decorate the functions that we want to instrument. We can add annotations. Now, like again, subtle difference between annotations and metadata. They both function in a similar way. Like you're essentially adding new value to a trace. The subtle but important difference between the two, annotations are indexed, meaning they can be searched. So if you have metadata that you might want to search for across your traces, I would say use annotations. Metadata similarly adds additional meaning. It enriches the trace, but it's not searchable. So in this case here, I'm choosing to associate the log key, like in the metadata, and I'm passing in the actual log stream. So like if I needed to go back and say, all right, what log did this trace, or what log is this trace associated with? Like where can I go to find more information? I know it's there. Like I can look at the metadata in the trace and walk it back if I needed to.
So a way to think about this that's very helpful is if you troubleshoot by a specific data field and you need to look up information by that data field, it's probably an annotation. If there's additional information you look at after you find that record, it's probably metadata. Can you scroll back up for a second, Brian?
Sure.
There's one other thing I want to call out here is that you also have the ability to pass in patched modules to come through. And to get that information that we got from requests, literally all we did was we passed a list with the word requests in it. So these are not things that are going to be horribly onerous for us to be able to do. You don't have to go find instrumentation libraries for each of your favorite ones. Say you like HTTPX, just swap it out. It's ready to go. Postgres or PsychoPG2, all kinds of PyMongo, you name it, it's probably in there. If it's not, it's really easy to extend to add it.
Yeah, so. Like I would say consult the AWS documentation for Lambda and X-Ray. They actually will list out the different modules that are auto-instrumented. Now jumping back to one other function. This is the OTEL function. Earlier I mentioned, and I'm going to wave my hands a little bit. I'm not going to ask you to read the code or my Vim diff. The code between the instrumented Lambda function and the OTEL Lambda function are really, really similar. The only difference is I'm not including the tracer and I'm not including the annotations, right? And the function decorators. Other than that, the code's the same. I mentioned earlier that we're able to get this zero instrumentation through the use of a Lambda layer. So I want to call out and just show how that's actually done. So again, I'll show you where the OTEL function is and how that's defined. So here I'm declaring the function. I'm specifying where the actual code is stored, what the Lambda handler is. Now, Dan mentioned earlier, tracing is a property that you can associate with a Lambda function in SAM. If you set it to active, what that means is AWS will actually add a trace ID header. So Lambda can add that header if it's not already present and propagate it to other services as well. So if you use Lambda with SQS downstream or SNS or API gateway, so if you're not familiar with API gateway, it's, as you might imagine, it's an API gateway that you can put in front of a Lambda function to trigger a function invocation based on an HTTP request. This is basically what gives you the ability to see a holistic view of what's happening in your serverless applications. Pass-through here means basically if a header is already added, cool, I can add my trace to it, but I won't create a new one. In this case here, I could have probably actually removed it altogether. But I am calling out the layer, right? Now the layer here, this is a fancy way of saying include the one of the Lambda layers here, depending upon the region in which I'm deploying my Lambda function. Again, nothing magical here. This is a This is a layer that AWS creates for us that we can take advantage of. If you wanted to create your own OTEL layer, you certainly could. Nothing wrong with it. It's an open standard. You can package up your own code and SDKs and APIs.
And if you're wondering what the standard is, it's the same thing as a Docker or an OCI layer. It's just a matter of how does it package and how does it come into the application. This is just the way that you specify it in the IAC.
Yep. Now, the important things that I want to call out, one is the environment. So I've defined a number of environment variables that are associated with that Lambda function that Lambda function can take advantage of. In this case here, I'll call out the exec wrapper down. So rather than beginning execution of the Lambda function with my handler, what I'm saying here is begin it here with opt OTEL instrument. That's code that's actually provided by the layer. So I don't have to do anything there. I just have to define where it lives. If you don't include it, the function will still run, but it won't actually do any OTEL data collection. I'm specifying a configuration file. So within OTEL, we have the ability to specify what happens. Think of an OTEL collector as a mini data pipeline for your telemetry data. You can specify where all your telemetry data is sent, whether it's enriched, all the good things. And I'm specifying the Honeycomb API and the endpoint as well. All of which to say is, I'm not changing my code, but I am passing in additional information. So here's what the configuration file looks like for my Lambda functions in particular. I won't profess to be unique here. This is basically pulled directly from Honeycomb's docs. So, but the important thing here is that the OpenTelemetry protocol, I'm specifying my exporter as the Honeycomb endpoint that I specified in my Lambda function definition, as well as the API key. So that's a lot of information coming at you, and I know we're coming up on time. I'm going to switch back. Actually, before I do that and we wrap things up, are there any questions about the code that you've seen? Yes.
So when we say no code instrumentation,
yeah, let's repeat the question too,
yeah.
just in case.
So the question is, what do we mean by no code instrumentation? What we mean is quite literally that in English. There is nothing that we did to that function that added any additional code. There's nothing that we did that added additional headers. There's nothing that we did to try and modify what that code did. What we did do is we enabled a tracing option within the IAC, which then automatically gives us the data that's necessary.
So the layer, like you can think of a layer that exists, earlier just gave you a really brief definition. A layer lets you share stuff. When Amazon takes the layer plus your function code in the execution environment, it basically does a merge. So so within the layer, there's an actual binary that's running. That's the collector. And in this case, we have the configuration file. So we're saying, all right, when you merge, there's actually a collector running in the Lambda execution environment. So we don't have to instrument our code per se. It just kind of happens.
Because the functionality provided by
Exactly. Yep.
Right.
Yeah. So that layer has the SDK. It has the APIs. So it'll take care of it. So your instrumentation code is 0.
So I went ahead and I put the code link up here. You can take a picture of that QR code. You can grab the bit.ly link at the bottom. Brian, I want to thank for doing an amazing job writing a huge amount of Markdown documentation to walk you through everything we just walked you through. So this is a good repo to show you what's going on, how to build it yourself, how to test it yourself, and feel free to steal all the good ideas because they're amazing.
Then just a few other things. I'll leave this up here for a moment or two. If folks who are taking pictures, if you wouldn't mind taking them sooner rather than later.
Any other questions while we're letting folks take a little bit?
I would like to. Oh, sorry.
Yeah,
Yep.
go ahead.
When you do manually instrument your code, do you guys find
Yeah, so the question is, when we instrument our code, do we separate what's there and instrument the logic, or do we allow them to more mesh together and have a harder time maintaining what's there? The answer is, like most things in the architecture world, it depends. If it's something that's very specific to the code that's being instrumented, I probably leave it in there. More often than not, I really like functional Python, so I will functionally write the thing that I want to be captured, allow a tracer to capture that or a logger to capture that method, and then I will invoke that as something that I capture to keep that code more maintainable and easier to read.
Yeah, like I would say there's almost value in having it lined up in code too, where it's very, very clear with what's happening. There's always a balance between instrumentation code versus code that's really meant for solving a business problem, right? And you want to minimize the instrumentation code because that's code you have to maintain going forward. But I think being more explicit about where that's occurring is probably better. Just my own opinion. Sure. Just a few, I'll say, parting thoughts before we really get to Q&A if people want to dive in. The need to observe serverless applications, it doesn't go away. Changes, but it doesn't go away. As developers and as operators, it's on us. I would say when it comes to logging specifically, log what you need and nothing more. Structure your logs and keep those logs for as long as you need. I can say from experience, having a log retention policy is a good thing. If you don't set a log retention policy, and this just isn't Lambda specific, if you're in AWS and you emit data to CloudWatch logs, if you don't set a retention period, it stays around forever. And Amazon will happily collect every month. So if you're not getting business value out of having something in CloudWatch logs, get it out. Either delete it or I would say a more likely scenario is send it to someplace that's more cost effective. So if you have exporters.
Yeah, so I'll tell you a very specific example to Capital One. We have to keep data for years. It's a regulatory requirement. There's very little we can do about it. We don't have to keep it in CloudWatch logs, though.
Yeah.
We can put that data to S3. We can put that data to a different aggregator. We can put that data into Glacier. There are we can put it on a Kinesis stream and run it into a data lake and then query it out of anything that we want. What we tend to do with this is we will keep the operational data that the teams need to troubleshoot an issue there for as long as the teams would reasonably need to troubleshoot an issue. After that, we ship it to something else. One, to get the cost down. Two, to put it in one place so when auditors come and ask for where's all your data, we can point them to one location and not have them making a bunch of queries through our log files, which we may need in order to troubleshoot an active incident. So I hope that's a way to make that a little bit more clear on where to do, but please don't keep it in CloudWatch forever. You're just going to spend money that you could spend on better things, like PyCon.
I would say as developers and operators, be aware of the metrics that you get out of the box from AWS. There are a lot. Be aware of what they are and be aware of this statistic to use. That's also important to make sure that you really get the meaning that you expect. If you need custom metrics, use embedded metrics format. Again, we're less opinionated about how you emit log data in EMF format. The good thing is there's already a solution in Python. I would encourage you to use it. Use Power Tools for AWS Lambda in Python. We've been talking about it more from an observability standpoint with logs, metrics, and traces. But it makes it a whole lot easier to handle a whole swath of other things. Input validation, event standardization, like it just makes your life a lot easier.
And in fact, most of the talks you'll hear this weekend on new libraries that make your life easier, they are wrapped up into Lambda Power Tools because AWS doesn't go invent this stuff themselves. They pull the ones that are the most popular and then they use them within the AWS Lambda Power Tools as we are codifying this is the best practice here. So if you're familiar with FastJSON schema or Pydanic or any of those kinds of libraries, even standard lib logging, All of those are what underpin AWS Lambda Power Tools. It's also an MIT licensed product, so if it's on GitHub, if you want to know how it works, you can take apart any piece of it and figure out ways to go then build it yourself if you don't like something that it's doing.
I would say traces are really, really good for understanding what's happening, you know, like within the context of a more distributed application. So lean in. If you're not big onto vendor-specific tooling like CloudWatch or Amazon or AWS X-Ray, know that open telemetry is a thing. There are open source options available to you. So if that's the direction you'd prefer to go, certainly there are options.
Yeah, please configure this for your needs and what you desire to do. The last thing that I'll say, well, with the exception of thank you for spending this hour with us, it's been great. We really appreciate all the attention and being able to talk to you about something that Brian and I are pretty passionate about here. We will be out in the hallway to answer any questions afterwards, so we can give this room to the next group and let them go. But please try your next application in a serverless context. See how much time you can save yourself, see how much money you can save yourself, and let us know if you have any trouble. Observability really has been the hurdle we've been hearing the most from our developers about. This is the thing that stops me from doing that. We built this talk to try and show it's not only something that you can do, it's something that's actually ends up better when you do it this way. So thank you all so much for your time.
Smile.